Hello, this is video number 41. I'll be talking about gravitational potential energy. So we've been talking about kinetic energy, which was energy due to motion, and then we related that to work. Well, in this video, we'll talk about a new type of energy and also related to work as well. So gravitational potential energy is not due to your motion, but is due to your position or your height above the ground. So whenever you have some kind of height above some reference level, then you have this energy which is stored energy. So we'll call it Pe sub g for gravitational potential energy. And it's defined as mgy. Your mass, 9.8, and I use y for your height above that reference level. Sometimes you'll see it written as mgh, that's fine as well. So the unit for this type of energy is also the joule, just like all energies, and it's a scalar. I made a note here that usually we set the reference level of having no energy to be at the Earth's surface. So what we're saying is that the ground here, we say, okay, that's a height of 0, y equals 0. So that means if y is 0, you have no potential energy. And then that's your reference level. And then anywhere else that your object is, then you can find its height above that reference level in order to know how much energy it has relative to that point. So this is a major difference between kinetic energy, where you didn't need that reference level. With potential energy, you need that reference level. And we'll talk about in this video about, why you have this type of energy. We'll see that in a little bit. For now, we'll just accept that it's mgy. So let's do a your turn here. Rank in order from largest to smallest the gravitational potential energies of the balls. Now this one is trying to trick you a little bit because you see arrows here, but these arrows represent the velocity, and your velocity has nothing to do with your gravitational potential energy. That just depends on the height. So if we use the surface here as y equals 0, that's our reference level, then 3 has the most height, it has the most energy. And then 2 and 4 have the same height, so they have equal energy. 2 equals 4. And then 1 would have no energy here relative to this surface. So it would be the smallest. So that would be the best answer choice, would be D. So remember, gravitational potential energy just has to do with your height, not with your velocity. Let's do a numerical example here. So there's a ball at the top of 2 steps. What's the gravitational potential energy of the ball on the top step when the 0 level is chosen at the ground? So that's what we said, that it's usually chosen at the ground. See the 0 level, that means that's our reference point, y equals 0. So then we have to find the potential energy of this ball. Well, we're just going to use mgy. PEG equals mgy. So the mass is 0.5, g is 9.8, and the height, well, from here to here, that's 0.1 plus 0.1, that's 0.2. So just multiply these 3 numbers, and that gives us 0.98 joules. So relative to the ground, the ball has this much energy. And now let's do part B, where we're changing the 0 level. We're saying, okay, what if we choose that 0 level to be at the top of the first stair, so right here? What if that's our 0 level? Well, to find the potential energy, we're still going to use mgy, but now the mass is going to still be 0.5, g is 9.8, but now the height, the y, is just from here, this is y equals 0 up to here, that height is now 0.1 meters. So we multiply that, we're going to get half of what we got before, because we have half the height. So 0.49 joules is our potential energy. So you may be wondering, well, what is the point of this? You said that we were usually going to pick the ground as the 0 level. Well, sometimes you don't care about how much energy it has relative to the ground. The reason being, without giving everything away, is that we're going to see that there's a relationship between this potential energy that we have, and let's say this ball was to fall down, there's a relationship between its kinetic energy. So let's say that we want to know what is the kinetic energy of the ball when it has fallen from the top stair, from the very top here to the zero level. Well, then we just care about what's the potential energy relative to this location. And then we can find out information about this ball at this location. So I'll say more about this later, but for now, the point of this example was just to really emphasize that whenever you're calculating gravitational potential energy, you really have to define where is your zero level. And most of the time you can pick the ground, but if you don't care about what happens at the ground, you might have to pick it somewhere else. And we'll do examples of that later on.